So what's another one we got here? How about SO3? How could we do SO3? You know, double bonds, right? Well, look, 6 bonds. 1, 2, 3. These are the gases, remember? SO3, these are ones that get up into the atmosphere, combine with water, make sulfuric acid. Acid rain, right? This is great too because people throw out highlighters. Well, when the tips of the highlighters get all worn out, we can still use it to color in the sulfur. Usually these things last forever too. So here's and isn't it great? You can count the number of bonds even too. 1, 2, 3, 4, 5, 6. You know, when you're using crayons, if you outline things, I learned, especially with a black crayon, it really makes it stand out better. So I hate to use pencil in chemistry, but if you're drawing, you can do all this in pencil, especially beginners. You know, use your eraser. I always thought erasers were cheating. So what do we have on the oxygens again? To make this more fun, we got our aliens, right? So think, there's lone pairs of electrons out there. Because of the octet rule, there's 2 when it bonds. So double bond is 4. There's 5, 6, 7, 8. So each of these will be a 2-headed alien. When they're ionized is when that 3-headed alien comes up. So like I said, I didn't like the alien theme, but this really is a powerful tool because electron pairs are what make chemistry what it is. I've been saying it for 15 years now. So there is SO3. That's a gas. It'll get up into the atmosphere. That's using all 6 bonds because oxygen loves to do double bonds. So don't be afraid of these big molecules that go beyond the octet. Because look, you have 6 bonding electrons, 6 bonding pairs. So 6 bonds has 2 electrons each, right? So you have 12 electrons in this outer, trying not to use technical terms, but you got to learn the word valence. Valence means the outermost. That's all we ever deal with in chemistry, unless it's nuclear chemistry, which really is physics, so don't even get me going on that. But there are 6 bonds on this. So that's beyond the octet. But it all goes back to the octet if you can remember that sulfur is just like oxygen. Remember H2O, H2S? The lone pairs of electrons. 2 bonds was the 4 and 2 lone pairs. But now what you'll find is when those lone pairs open up, they'll even split. So then you'll get single bonds, like in the sulfuric acid part. This is just 2 electrons here, 2 up there. Those pairs opened up. So even though there were 8 to begin with, now there's 12. 2, 4, 6, 8, 10, 12. This is real science, kids, and look how simple it is with crayons. So again, to make it look more fun, what do we got out here? We got some aliens, right? Oxygen aliens. Little green men, because the green is negative. So with the negative charge, remember we were doing this with ammonia. Negative north pole. I don't know what north or south is positive or negative, but just we're making it negative. N, negative, N, north poles for magnets. That's exactly what this is. It's called an electromagnetic force. It's magnetism, kids. So there was sulfuric acid with 2 two-headed aliens. Out here we had the H2S. Now what these are, I didn't want to draw them in because you get them confused, but there's two lone pairs of electrons out here. So the way you'll see it written in the book, they just write H2S when it should be HSH, but really it's polar, so it should be written H, big S, H down here, and then two lone pairs of electrons. I always circle them because it just makes it easier to distinguish them. So see how H2S, I'm writing this sideways, that's why it's so hard. H2S is just like H2O. It's going to be bent. Do you see that? Okay, here's our example. We were just doing sulfur, so let's do dimethyl sulfide. Now this is the way we drew it with the circle, but now we've got the Star of David. Let's see what we can do here. Six-pointed star this is. So a dimethyl, they're probably going to be on opposite ends. I think the lone pair would make that a bent molecule. See, the power of the star is we can make them bent. So methyls are just triangles, right? So there's triangle. Triangle. This is dimethyl. Di means two. Sulfide. Color out an S here to this would be like Superman here. Dimethyl sulfide. So that's a carbon. It's a carbon. These are lone pairs of electrons, so they're going to be fine the way they are. So where would we draw the aliens in? Got 2 points up here, so draw an alien in between there. So each of the points is now accounted for. Lone pair, 2 bonds. Now what does carbon get? If they're methyls, colored pencil, see if this comes in handy, huh? CH3, so there's 1, 2, 3. Now back to our technique. If we're done with that, let's color it in. Trusty crayons here, huh? Methyl's done. 3 H's and the bond to the C. Color that in. So it's great. You do it last with the crayons. That way it doesn't bleed your ink. And if you do magic marker over ink, it tends to ruin the marker, especially with yellow. We got to protect our yellows, right? Because they'll get all dirty. So we could still kind of outline this in green because electron pairs, right? If we got the color coding, let's use it. It's going to be negatively charged, so that's our green color coding, right? Little green men. Since we're yellowish here, we'll use a different pea colored green here.